to begin with, I'm very happy that you all have chosen us to be your professional guidance team. So thank you, and I hope this class will be really useful to each one of you in the way that you want it to work for you. Before we begin, let me introduce myself. My name is Swati. I'm a BTech Computer Science graduate. I am working as a quality analyst since 2004. So that's almost like 9 years or close to 9 years in the software testing field. I've been in the software testing field from the beginning of my career, and it didn't happen by choice. It happened as an accident, and I'm really happy that it turned out that way for me. So the fact that you all are actually consciously choosing this class as to get into this field is a wonderful beginning for all of you, and I wish each one of you a very a warm welcome, and I wish you all a good luck, and I hope this class will be really useful to you again. Coming back to my introduction, I'm a CST and CSQA certified professional, and I will be facilitating this class. So before we begin, I'm going to let you know how this class is structured and how we are going to approach learning the QA. So you all must be knowing from the orientation that it is a 5-week session, 3 days each week, Monday, Tuesday and Wednesday. And there are a couple of things that we are going to cover in this session. First is we are going to understand all about manual testing. The in-depth knowledge about manual testing we are going to get here. So this means we are going to talk about all the documentation, the templates, we are going to talk about what defects are, etc., etc. We are going to cover manual testing topics from the beginning to the end, everything included. And then the next important aspect that we are going to cover is the automation testing part. Here, this will not be any tool specific training here. I'm going to just give you basics about how to approach automation in case you choose to do so in the future. So again, the automation is limited to functional testing. We are not going to look into performance testing or security testing or anything in depth. It's only about functional automation testing. And the next thing, an important aspect of this training is going to be tools. We will look into some of the very popular test management and test automation tools that are in the market. So this will give you a good understanding and make you job ready if you're trying to apply for a position outside, and if you need some kind of a working knowledge about the tool, this will be a good way for you to start. Again, since taking into consideration the time and the scope of this class, we are not going to go into a greater length, a greater depth of detail. I'm only going to cover the basic aspects, and you are always welcome to dig in a little deeper and come back with the questions. So the next aspect is certification guidance. We will talk about the popular certifications for an entry-level software professional that are available in the market and that can be useful for your career. So certification guidance is going to be an integral part of this class. And the next thing that we are going to do is resume guidance and interview preparation. Again, these will be these three aspects, the last three aspects, the certification, resume and interview, I understand are not applicable for everybody, because I know that some of you are already working and just want to understand the standards and understand the concepts of testing as a subject, but not in terms of finding a job. So for those of you who are interested in this guidance, we'll just have 1 or 2 sessions on the last 3 topics, but for the rest of them, I will be talking to you on an individual level and understanding your needs and guiding you in a way that is relevant to you. Okay? So this is how the course is structured. Again, apart from these, you're going to get an ebook that is authored by Vijay, who is the co-founder of this course. And you're also going to get ISTQB material. And the most interesting aspect as far as I think is the live project. So for the first week, we'll spend some time on understanding the testing, basic testing concepts, and then we will go about learning everything via the live project. So week 2 is when I will introduce you all to the live project, and we'll start working on it. We will work on it in a way that it simulates the real-time world. So that will give you a good understanding of how testing projects go on in the real world. So that is the course structure on a very high level. The detailed topics are here in the training plan. So I have actually listed the topics week-wise. Again, this is a loose structure. We might not follow it to a T, but I will make sure that we will cover all the topics, not necessarily in the same order. Okay, you're going to get this document after this class through an email. So I'll share it with all of you, and we'll make sure that we cover all these topics. Okay. And the next thing I want to let you all know is the format of everyday's class. So in everyday's class, we are going to cover 3 aspects. So the class is going to be divided, or the topics that we are going to cover are divided into 3 aspects. First is vocabulary. We understand that every profession comes with a set of its own words that are, very, very commonly used on a daily basis, right? So the same is true about a software testing profession also. There are some words that we use very, very often during our, careers, and it was very important for us to understand what each of these words mean. So to be a successful tester, I think it is very important to have a successful testing vocabulary. So we will cover 1 or 2 words, or they won't be just words. We will cover the topics surrounding those words every day in a class, 1 or 2 of them. We'll do that. And the second aspect that we are going to have is a technical topic. So the primary focus of everyday's class will be basically on the technical topic. Okay. Vocabulary will just be 1 or 2 minutes, maximum a 5-minute part of our class, but most of the time we're going to spend on understanding the technical subject. And then we are again going to cover some non-technical aspects, like how do you communicate, how do you write emails, and the other soft skills that are associated with becoming an IT professional. Those are the things that we are going to cover in the non-technical part. So these are the 3 aspects that we are going to have in each and every class. Okay. Okay. Now that we understood what we are going to have in the class, we will see how each class is structured, the structure of the class. So we will begin exactly at 7. And we will, in everyday's class, we will have, as I said, those 3 aspects. We will discuss that. So basically, we'll discuss the topics of the day firstly. Then secondly, every day you're going to get an assignment, because we believe that, an information dump is basically not you're looking at. We understand that here. And the only way I believe that you can learn a certain concept is by applying it, by using it, by learning, by doing. The only way you can learn some concept very, very thoroughly is by doing it. So every day I am going to give you an assignment. Again, it's not going to be something that will take up hours of your time, or that will need you to refer a couple of documents or read books and then come up with answers. No, it's not going to be like that. It's mostly going to be the practical application of the topics that we studied in class that day, or we discussed in the class that day. So that's going to be the assignment part, and at the end we will have a Q&A session. Alright. So again, you don't really have to wait for the Q&A session for you to ask your questions. If you have a question related to the topic that we're talking about right now, you can always raise your hand or put it via the chat window, and I will address it immediately. But if you have a topic that you need to discuss at length, we will have to address that in the Q&A, where I will unmute the rest of the participants and you will have an opportunity to speak. Again, at this point of time, my only request is to be little sensitive about the entire team, and make sure the noise levels at your end is low and you have the right, infrastructure to be able to join in the call. So that is how the class is going to be structured, and depending on how we are doing with the length of the topics and things like that, we'll also take a 5-minute break if you all need it. So that's how the class is going to be, and also after every session you are going to receive an email on how to access the recorded video. So every class is going to be recorded. Every session video is going to be provided to you, and you can watch it as many times as you'd like to really understand the concept. Or if you miss a class, you'll be easily able to catch up, and feel free to email me or Vijay anytime during the class or after to have your questions addressed. So that is a little bit of the basics about the session. Now we'll just get into the actual concepts of today's class. Okay. Today what I'm going to discuss with you all is, today's vocabulary is going to be, we are going to understand what is a software, what is domain, what is technology, what is a platform, and what is testing itself. So these are the 5 words that we'll try to define and understand today. Again, we are going to start at the beginning because I'm sure a lot of us are already acquainted with all these words, but I want to really start at the beginning and make sure that we are all on the same page. So we are going to again take some time and define these concepts, even though they are very, very basic. So what is a software? Software is nothing but a certain set of programs or a piece of code that work to actually accomplish a certain task. Right? What is for example, the software that we know is Google, right? What does Google do? It takes in an input, performs a search, and gives the search results as an output, right? So what is Google? It is nothing but a set of programs that facilitates the internet searching, correct? So every software has a purpose. Every software in turn is written using certain technical language. So basically a software is a set of programs. Okay, so that's simple enough. Let's move on to what is a domain. So this is one of the questions that gets asked most often. What domain are you working on? How many domains have you worked on? Or what domain expertise do you have? And this word really intimidates me sometimes too, because when I go to a interview or when I look at a job description, there is always a domain that I haven't worked on. So I always feel like I am not experienced enough to be able to successfully work in a certain domain. But in my opinion, domain is simpler than what it sounds. Domain is nothing but a key business area, right? So some of the examples of a domain are e-commerce, banking, telecommunications. Again, these are some of the examples I'm giving you. Okay, so e-commerce in the sense sites like Amazon, Amazon.com or Walmart.com or anything that facilitates business to happen via a website is an e-commerce website, right? So basically what is it? It is a business area where online shopping happens, right? Banking is the same. Whether it is Bank of America or ICICI, all the sites, they come under banking. So basically any kind of business area will get grouped into a domain, right? And now a lot of times I get asked this question: how do you gain a domain knowledge? See, there is no right answer or straight answer to this question, because in my opinion, all of us, we do have a good understandable working knowledge of all these domains, right? We all have gone onto Amazon.com and shopped so many times, right? We all have bank accounts and we all have like online accounts, and we do work with them. We do perform some transactions on the banking sites. The same thing is applicable to the telecommunications or any other site, healthcare site. It doesn't really matter what domain a particular website or an application belongs to. In my opinion, every software comes with 3 components, right? It has an input, it has a manipulation. I will explain this later in a bit. And then there is an output. So what do I mean by this? Again, let's go back to our google.com example, right? Say this is my google.com. And what do I do? So let's take google.com and we'll try it. Okay. So I have this site google.com and I have a field where I can search for anything that I like. So I'm going to search for test. Okay. Now what really happened here? I got my search results. So now there are 3 things to it. The input I gave is test. The output I got is the search result, right? And then the manipulation is basically the business logic or the algorithm that gets performed at the back end of the google.com site and provides you with this output. Correct? So every website, in my opinion, irrespective of the domain it belongs to or any application, not just website or any other application, basically has these 3 components. So as long as we understand that there is a certain input to be provided, a certain logic that happens, and then an output that gets generated. So these are the 3 things that we need to keep in mind. and how. So the domain knowledge is basically helpful in understanding how this manipulation is happening, right? So if I am an expert on a search engine, I need to understand how this algorithm is being written, correct? So this is where a domain knowledge will help you in understanding these algorithms and the manipulation functions that happen on the back. We understand that depending on certain businesses, certain logics get applied. So this kind of information on what algorithm is getting executed, or what manipulation operations are going to happen, this you will get through experience. But my suggestion to everybody is, don't get intimidated by a certain domain. Do not go into working on a certain application thinking that you do not possess the domain knowledge, because all the websites or all applications are actually created for users who are actually people, and we as consumers, we have at one point or the other used these applications, and we do know how to work with them because we are doing it on a daily basis, right? So the only difference between using something and testing something is, so say for example, I am doing this search, right? When I search for test, there are some, say, 10 results that I am getting displayed. So let me explain that. So my input is test, right, on the Google side, and my output is 10 links. Say I am displayed with link 1, link 2, test results, and so on till link 10, correct? So as a user, so if I am a user and link 1 is what works for me, I will simply click on the link 1 and be done with it. But if I am a tester, I need to make sure that all these links are being displayed relevantly, or if I am able to navigate through the links that it displays, I am only going to get a little more technical and a little more skeptical, right? When I am a user, I am going to definitely assume that when I click on the link 1, it is going to work. But when I am a tester, I am skeptical. I am not sure whether it will work or not. So I will never go into clicking this link with the assumption that it's going to work. So this is where I say that one of the most important qualities that a tester should have is the attitude. So let's, since the topic has already come up, let's list the qualities of a tester. First thing is attitude. You should be skeptical. That means not assume that things are going to work. So that is one of the first and foremost aspects that we need to keep in mind. And the second thing, very important, is attention to detail. You have to really pay attention to what these links are, and how many links are being displayed, in what order, do they look good on the screen, or are they all garbled? So these are some of the things. All the details are a tester's job. So attention to detail is another important attribute that a tester should possess. And the next thing I would say is communication. No job in a software world or in an IT world, or for that matter in any field these days, can be done by yourself. So which means that there is always teams involved, right? A team that you are a part of, or the team that you report to, or the team that you interact with. There are multiple teams involved at every point of time in a software job, especially in an IT job. And this is so much true for a QA job actually, because we QAs are the ones who test the software at the end, and we have to be on a regular touch with the users, the developers, and the concerned, everybody, all the concerned people. So for a tester, it is very important to have good communication. Okay, Steve, let's just take a little check here. Can you all hear me? Alright, Yamini, I'm not sure why you're not able to hear me, because it seems to be going okay. Why don't you give it a try now and let me know? Okay, so let's get back to our topic. So the next thing that a tester needs to have is the technical knowledge. As I said, in a domain, understanding that manipulation functions or the algorithms that go behind it is important. So technical knowledge is important. Again, I don't agree with the concept that communication or attitude or technical knowledge, any one of them takes precedence over the other. In my opinion, all three of them are a very important skills that testers should have, and we should always try to develop our skills in terms of these three areas to be able to be successful in this field. Okay, so that is domain, and the next thing I want to define is technology. Again, you will get a lot of times, even in usual discussions, you hear like, what technology are you working on and things like that. So basically, a technology is nothing but the language that is used to build the software, and probably the databases. For example, I have a website that I developed in Java, and the backend is a DB2 or DB2 website, or a DB2 database, or a SQL Server database, right? And then the technologies that I'm working on become these. Okay, so this kind of technical information, like what language the site is built on, or what databases it uses, or what web servers it uses, all this information becomes the technologies on which you work. So that's technologies. And the next thing we are going to discuss is platform. What is a platform? So again, platform is nothing but the target environment. It is the target environment on which your application is going to run. For example, google.com is something that runs on both Windows and a MacBook, right? But then if I have an application, some application like a YouTube app or something, that's going to run on mobile phones, right? Probably they have an Android system or something like that. So basically, the target platform or the target environment where any application or any website runs, that becomes the platform. Okay, so I hope these these terms are a little clearer to all of us, and please feel free to ask questions if you do have them. The next thing I want to talk about is, excuse me one second. So, Yamini, are you able to hear me now? Okay, we'll just continue. The next thing I want to discuss is what is testing, right? We have defined all these terms. So let's go ahead and define what testing is. Testing is basically an activity that is performed on a website or application to uncover errors. So in the real world sense, testing is basically, in my opinion, involves a lot of common sense. So it is nothing different from what we perform on a day-to-day basis. For example, when you are actually buying a car, or trying to buy a laptop or something, you always give it a try, right? You always try to test drive a car or things like that to make sure it is something that fits your needs, or to make sure that it works the way you expected it to work. So that actually, in my opinion, is testing. Only difference between testing in the real world and in an IT world is that in an IT world it's a little more formal, and it is a little here we are trying to not just understand if the software is working the way you want it to, but if it is not working the way it is not supposed to. Okay, so testing is again an activity that is done to uncover errors. So why do we have to test, right? In a software world, I am a developer, right? I create a website, correct? This is my website. Now, when I'm creating it, won't I go ahead and test it? I am going to test it, right? But the point is, developers cannot always become testers. Why do you think there is an independent team of testers that we have So we are the independent testers, right? That is what we are making a career on. So how come there is a need for a separate group of people to perform a test on a website that is already built? So the answer to that question is, lot of times when when a developer develops a software, he does not because you keep working on it so many times, it is possible that a developer might overlook some defects, right? And also testing in itself is a complete functionality, correct? So say there are like 10 features in a website that I have developed, 10 features that I developed as a developer. It will take me, for example, if it took me 5 days to develop it, it will definitely take me 5 days for me to test it, right? And then since I've been already working on it for 5 days, there is a higher chance that I might overlook some defects. So testing is an activity that takes time and dedicated effort. So that is why there is a separate testing team most of the times. Okay. So these are some of the reasons why there are different independent testing teams. Also, lot of times we all have made a decision to become testers. Testing is a very wonderful opportunity for you if you are a startup, if you are a starter into the IT field and you are looking for a beginning into this career. It is a wonderful field because testers have a 360-degree view of the entire software. So it's a good opportunity for you to learn how a certain system works. It is very easy for testers to gain domain knowledge very, very quickly. So testing a job is a perfect IT beginner's job. So and then the scope of it is huge. So there are so many instances when testers become business analysts and sometimes developers, or testers become test managers at a very, very early time. So testing is a wonderful beginner opportunity. Okay, so the next thing, why become a tester? As I said, the scope is immense. It's a wonderful career chance. And what qualities should you have? As I said, you should have the attitude, the right communication, and the good amount of technical knowledge. So let's just try to understand, what do testers do on a daily basis? What does the job responsibility of a tester include, right? So tester's job is first and foremost testing. That means working on an application and trying to uncover the defects or errors, right? So that is the first job. Again, there are other supporting activities here. Testers most of the time spend like 50% of our time we spend on documentation. For a tester's job, documentation is very, very important. I'll try to explain why. Say there are 10 features in my site, say 5 features, okay? I have 5 features that need to be tested. And I have 2 people working on it for 2 days, right? Say I have tested feature 1 and it seems good. And I have tested feature 2 and it's good. Feature 3, feature 4, feature 5 and everything looks good. I did not find no bugs, right? The intent of my activity is to actually find bugs. But what if I don't find any bugs, right? At the end of 2 days and 2 people working on it, so 2 people, 2 days, if not for bugs, I have nothing to show for my work, right? So this is where documentation plays a part. So by documenting each and every part of your activity, like for example, test 5 features. If I have documented that feature 1 takes 10 hours to test or something like that. I mean, I'm just giving you a rough idea. By documenting this fact and documenting why this takes 10 hours and things like that, there is a higher scope of success and there is a higher scope of showing the return on investment, on showing that what is the work that you performed and how it is contributing to the overall quality of the product. Okay, so as a general rule, testers have a lot of documentation, and the next thing testers do is participate in a lot of meetings. So as you're seeing here, there is a lot of there's a lot of communication aspect involved here. So there are going to be like status update meetings and defect management meetings. So there are a lot of meetings that the testers attend. So here this is where both written and verbal communication play a major role. So the more efficiently and correctly you're able to express yourself, again both written and verbal, the better it is going to go for you. So these are some of the activities that testers perform on a daily basis. Okay. Alright, so that covers all the non-technical aspects. So I'm going to unmute you all. If you have any questions, so feel free to let me know. And I'll take that before we go to the main topic of today, which is the software development lifecycle. Any questions, team, so far? I'm so sorry, Yamini. I don't know what's wrong, but I somehow cannot figure out why you are not able to join the session. Is there any questions, team, so far?
So far, so good on my side. Thank you.
Alright, then I'll just continue and let me know if there is anything. Great. So, what is a software development life cycle? A lot of times during informal conversations that we hear among IT professionals, it gets asked that what stage is your project in? What phase of the SDLC is your project in? So basically, what SDLC is it is the process in which a software gets developed. Let me write that down. SDLC is software development life cycle. So this is basically the step-by-step procedure of how a software gets developed from the time a client approaches a software service provider. So let's understand the roles here. Okay. So I am the client, or I am the person who has a business. Say I am a car dealer. Okay. And I want to computerize my business, and I have no idea how to do that because I have no idea, because everybody keeps telling me that computers are the latest trend, and I want to try my hand at it. I want to see how computerizing my car dealership will help me enhance my business. Say that's my business need. What do I do? Because I'm not well versed with building the software, I approach a service provider. Software service provider. So this will be anybody who will build and test and give me the software as a package. Correct? So now, what do you think I want to do? My business goal is simple. I want to computerize and make it easy and accessible to wider audience. So that is my goal, because I am a completely non-technical person, and beyond this I have no idea on how to do it. Now I approach a software service provider. So an underlying process that goes on is a couple of providers are usually consulted. Again, this depends. If there is a good client and service provider relationship, they will approach one provider directly. But if not, multiple providers are intimated that this client is in the need for a business. So again, each service provider takes the ultimate business goal. They will analyze it. So first thing that happens is analysis. So analyze this goal and see if this goal can be met or not, and then team, just excuse me 1 second. Yamini, can you log out and log in back? Have you tried that? Okay, I think Yamini just left, and I think she's going to re-log in. I hope she'll be able to hear me okay this time. So yes, the first thing that happens is analysis, and then there is a phase called the proposals, right? So what happens in the proposal phase is, so we all know that to build a software it takes time, people, infrastructure, right? Infrastructure in the sense you need a computer, the supporting software, probably a database. So all this, and then there are technology considerations. So all this information is studied, and a proposal in terms of money, how much money is it going to take, how many people, how much time, and also, you know, all this high level information is again presented back to the client, and the client will make a decision of choosing the software service provider. Alright, so that is the inception. Again, as a tester or as an IT professional, we will not have an insight into this process at all. This is done by the high level management, but but it's a good idea to, you know, understand the underlying process. Okay, so once the proposals are made and a software service provider has been chosen, that is when the SDLC begins. So the pre-activity or the prerequisite for the beginning of an SDLC to happen is the proposal's acceptance and the software service provider is chosen. Okay, so that is the beginning or the prerequisite for the software service SDLC to begin. So now let's see what are the different phases, what is the purpose of each phase, who are the people involved, and what is the input to this phase, and what is the output. Okay, so this is what we are going to discuss in detail for each of the phases in the software development lifecycle. Again, this is one of my favorite topics to begin with because this will give you a good idea about all the people involved, not just in a testing project, but in the remaining teams of, you know, any software project also. Again, it will give you a good idea of what happens at each step. So this is one of my favorite topics to begin with. Let's get started. First, let me just list all the phases that are in here. The first SDLC basically consists of 6 phases. The first phase is the initiate. The second phase is define. The third is design. Code. Test, and the 6th is deploy. So basically every software project goes through these 6 phases. This model of a software development lifecycle is also called a waterfall model or a linear model. There are other models of software development lifecycle called waterfall, spiral, and agile. But the most commonly used one is waterfall, but these days agile is gaining popularity. We'll discuss agile and waterfall in our sessions. Today it's going to be waterfall. Maybe tomorrow we'll take up the agile. Spiral, I'm not going to do the spiral SDLC model because it is just a slight variation of waterfall model, and frankly in my experience I have not seen a lot of projects use it. So if you have an academic interest in this topic, please let me know. We can discuss that offline, but in the class we are not going to discuss the spiral model in detail. Okay, so as I said, these are the 6 phases of a software development lifecycle. Now let's see what each phase is. So as we discussed, first the client approaches a software service provider, correct? So the people involved. So the first phase is initiate. In the initiate phase, the people involved are the client and the software team, which is nothing but the project management team. And the software service provider has a team, a dedicated team who is going to work on this particular project that the client has brought to you. Correct? Now, the whole project is usually headed by a project manager. At this phase, a project manager, a client, and a business analyst are involved in what do they do here? They're going to get the client's requirement and analyze them and make sure they are buildable. Correct? So when I say make sure they are buildable, what do I mean by that? Probably I am somebody who is a computer novice and I don't know what a computer can accomplish and cannot. Say if I come up with the requirement that a Microsoft product, a Microsoft Word should be able to write what I'm thinking about. So that is something that is not possible. It cannot read your mind. So if I come up and say that it should accommodate the writers to write what they want to write, maybe Word can enhance your experience of creating a document, but it will not be able to create the document for you. So these are some things that we need to really analyze and understand. So make sure that they are buildable and make sure that sometimes even if a requirement is buildable, the said company might not have the knowledge base, might not have people or the technology that is required to accomplish a certain client's requirement. So in that case, we need to make sure that that is something that we are addressing. So all this high-level information is basically all this high-level analysis is basically done in the initial phase. Okay. So the input for this phase is the proposal document, as we talked about. So the proposal document and the client itself, right? So the client meeting or the client's discussion, whatever comes out of discussion with the client, that becomes the input for this phase. And what is the output? Generally, all the client's requirements are documented in a business requirement document here. The first document that gets created in an SDLC is the business requirement document, shortly addressed as BRD. Apart from this, a high level, since we already agreed on a certain time, time frame, right, with the client. So a high level project plan is also made here to understand how many people we need or what technologies that we are going to use. This kind of information is put in the high level project plan. Again, none of these documents are frozen here. That means an initial versions are created. That doesn't mean these documents are final. As and when changes happen or as and when you have more inputs regarding a certain aspect, as and when you go through this SDLC process, you will be able to make these documents very comprehensive. So at this level, they're basically skeletons having very basic information. So we will look at samples of all these documents as we go through the classes, but for today we will try to understand this process in detail, right? So in a way, initiate phase is basically the initiation of a project. So here a BRD project plan, probably a scope document, high level scope of what's going to be included, what's not. So that level of information is done here. So yeah, that's what happens in an initial phase. So more than so at this phase, frankly, a testers. Let's create another column because we are mostly concerned with our testing jobs. So tester or QA team's involvement is something that we will try to understand through each step. At this phase, ideally, QA team needs to be involved, and QA team needs to be able to, needs to be able to, make certain decisions about whether a requirement is buildable or not. But frankly, QA team is generally not involved at this step. Basically, the high-level management, as I said, the BAs and PMs, these are the people that are mostly involved in this step. QA team involvement is basically no involvement or minimal involvement. So even if a QA team is involved, it will be at the level of a managerial, at a managerial level, but not the individual testers. Okay, so the next phase in the SDLC is define, right? So define phase is where the question of what the product is going to be gets answered, right? So my client came up with a requirement saying that we need something built to computerize his car business. So I need to come up with exactly what the product is going to be like. So is it going to be a web product? Is it going to be a web application? Or is it going to be accessible through a URL? Or is it what all facilities is it going to provide? So these are the kind of information that are actually defined in the define phase, right? So this is where it gets a little technical. At this phase, the people who are involved are PM as a project manager, the BA, business analyst, and the QA are also involved, and we will talk about what is the QA's involvement in a bit. And the client is not involved here because at this phase it gets a little technical, so the client is not involved and the development team is involved here. Okay, so define phase, again we'll come back to the QA involvement. We'll talk about what is the input here. The input again is the BRD. In each phase of the SDLC, it is important to remember that the output of the previous step becomes the input for the next step. So when you're going to work on the define phase, you're going to work on it based on the outcome of the initiate phase. So the BRDs and the scope documents and the high-level project plan, these become your inputs. And the outputs that come out of it is again a modified project plan. As I said, once the project plan is created, that doesn't mean it is going to stay that way constantly. As and when we have more information, now that we have more information of what the product is going to be like, we're going to be able to put in more information into project plan. We're going to be able to make it more comprehensive. So project plan is basically like the roadmap. That is what everybody across all the teams, like the PAs, DM, BAs, QAs, everybody are going to use the project plan as their input. So the project plan always is like the roadmap, the direction that it's going to give the direction to the rest of the team based on their roles and responsibilities, or on the tasks that need to perform, or the milestones that the project is supposed to achieve, and things like that. Okay. Now that the QA team is involved in this step, there is a high-level test plan that gets created. So these are, and then the development team is going to come up with a functional definition document, or the functional requirement document. It's called by either name. So the output for this step is a project plan, test plan, and an FRD. Now, how can we make a test plan at this step? Right? Let me explain you what is the difference of QA and QC. This is also a very commonly asked interview question. And it helps to understand this concept early on, because as a general practice, it is a good idea that QA teams are involved from the inception of a project to the end. So what is QA and what is QC? QA stands for Quality Assurance. QC stands for Quality Control. Say I have this website that I built. Okay. Quality control means for testing this application after it is built to find errors. So this is basically testing itself, right? So the intent of QC activities is basically defect detection. That means you're trying to find a defect. QA is nothing but the important point to note in quality control is the level of involvement or the time of involvement. The time of involvement is after the product is built, right? Quality assurance is nothing but getting involved in a SDLC or development process right from the beginning, and the intent of this activity is defect prevention. Correct? So always QA team's activities should be focused more on defect prevention than on defect detection. Okay? So generally testing teams are not just involved after the product is built, they are usually involved even before the product has started being developed. So this is again, defect prevention is a much better situation than actually correcting it after the defect happens, right? So that is exactly why QA teams get involved here. At this point, once all the requirements are being listed out, the QA team performs a feasibility analysis and makes sure that the requirements are in accordance with the client's business needs. So that is the testing team's intent of getting involved early on. Okay, at this phase, what does the testing team do? Testing team performs a parallel activity with the rest of the team. So at this phase, what we will do is we will create a test plan. Again, at this phase, there will be high-level details like schedules, people involved, or milestones. So again, high-level details. Just the way project plan is a dynamic document, test plan is also a dynamic document. As and when you have more details, you will have to go back and update it on a timely basis to make sure that it has the most current information that you can have. Okay. The next question is design. The next phase is design. So the design phase, the purpose of this phase is to design a solution. The main actor in this field is the development team. The difference between define and design is, say I am the car dealer. Correct? I am the car dealer and I needed a site to be created. Now in the define phase, I will say there should be a viewing of the cars that need to be sold, or there should be a facility to buy car, there should be a facility to sell car. Okay, so that these three are the menu options that need to be there, right? So that is the define phase. How does the define phase differ from the design phase? In the design phase, you're going to get to the technicality. That means, how do I create this menu option? Am I going to use a Java class for it, or am I going to use a VB object for it? So programmatically, how am I going to translate this functional requirement into a technical requirement is the focus of this step. So since this level of technical knowledge is basically present with the development team, the dev team is the major actor in this step. So having said that, it does not mean it is limited to only the development team. Again, as a prevention method, QA team also gets involved. BAs are involved. BAs are basically not involved at this step. So we will come back after this step to understand what a BA does. PMs are involved, but on a very high level. So basically, development and QA team are involved here. The major emphasis is on the development team. At this step, what becomes your input here? The FRD, because the functional, as I said, the output of the previous step becomes the input for the next. So the FRD becomes the input for it, and at the end of it, the output for a design phase is technical definition document. So the output for design phase is the technical definition document. So what does the QA team do here? It is going to update the test plan. How does it update the test plan? So you have these high-level, requirements, correct? You have this high-level information. For example, here you need to verify buy car, verify sell car, verify view car. So as a tester, you know that these are some of the aspects that you will have to test. So you will make a high-level list of aspects that you need to test. So my list will look something like this. Test view cards functionality. So basically what I'm doing here is I'm trying to come up with a list that I need to test going forward, right? Test the buy cards functionality and sell cards, and in the buy cards, can I cancel buying after paying? Couple of details. Depending on how detailed the FRD is written, you will come up with the high-level conditions that you will have to check. These are called the test objectives or the test scenarios. So while the design phase is happening, the testing team will write the test scenarios and update their test plan, put it in the test plan, right? So at this phase, the QA team will have a high-level understanding of what it needs to test. Okay. Sunil, did you have a question? I see that your hand is raised. Alright, if you do have a question, please put it in the chat window and I will try to address that. Okay. Alright, let's just move on to the next phase, which is the coding phase. Okay, before we get there, we'll try to understand what a BA does. BAs are business analysts, as we talked about. Business analysts are basically people who have a good understanding about a certain business area or a certain domain, right? So business analysts are, you can call them SMEs also, subject matter experts, because they have a good understanding, as I said, of the business. They understand, popular trends, right? For every, say, e-commerce. Say there is an e-commerce business. So what does an e-commerce business include? It needs like a shopping cart, correct? Or it needs facility to search. It needs a facility to log in or create registered members, right? And things like that. So it is business analysts who will have a good understanding of these functionalities because they are well versed with this business. So they will be able to come up with solutions on how to achieve this shopping cart feature in your site very easily. So business analysts are basically people who you can call them SMEs. SMEs are, again, this is another word you'll hear often. This stands for subject matter experts. Sometimes SMEs can be business analysts. Sometimes SMEs can also be clients. Because essentially at the end of the day, you're building a software for a certain client. So who would know about their business the best? The clients. So usually SMEs are people who belong both to, the client side. They could be somebody who belong to the client side, or they could be somebody from the service provider side who are called the business analysts. Okay. In the coding phase, as the name suggests, the development team is going to create the code. So what happens in the coding phase? Let's look at this with an example. Say I have, as I said, view cards, buy cards, and sell cards. So these are the three modules I have. Say I have 3 developers, right? So 3 developers, let's say they divided the work equally and each one of them is going to work on one functionality, right? So now I am developer 1, I build view card. So I'm writing the code basically, and similarly it is same thing is going to happen for buy cards and sell cards. Now this piece of code, this unique piece of, the chunk of code that each developer writes is called, you could call that a unit. Again, in the view cards itself, this developer might divide it as day 1's work as 1 unit, day 2's work as 1 unit, right? So basically the individual chunks of code is called units. Units are again tested. Each unit of code that a developer builds gets tested. Who does this testing? Since we as testers don't have a good understanding about the code, right? We don't understand, we are really not equipped to understand a Java code or a VB scripting or, a C language code or a machine language code. We really are not equipped. See, some of us might have that expertise, but that's not a requirement of a tester. So most often we are not well equipped with understanding that code. So who is going to test it? It is the tester that tests it. The tester will check each unit of code to make sure it is working fine or not. That phase is nothing but unit testing, right? So at this phase, what happens is code is developed, and the parallel activity that happens is unit testing. And the input for this is the FRD and the technical definition document. And what happens? What is the output for this for this phase? It is the code that gets built and also unit testing results from so far what we've learned. Now, so after the unit testing is performed, the unit testing results are the output of this phase. Now, I am finished with developing the 3 modules now. Those 3 view cards and buy cards and sell cards, I'm done with that. Now my website is an integration of these 3, right? The view, buy, sell. My website is complete only when everything is done. So the way my business function is going to work is, first I'm going to view a car, then I'm going to buy a car, and in the future I might sell a car, correct? So this means that all of these 3 functions should work in conjunction with each other, should be able to interact with each other and work harmoniously. How do I make sure that they are working correctly? The next phase after the unit testing is called the integration. That means units of code are integrated with other units of code, right? So here view functionality is integrated with the buy functionality, and these 2 particular units of code should work correctly in integration. Again, this integration and understanding this integration takes a little bit of technical knowledge. So this is basically integration testing is also basically performed by developers, right? So integration testing is also performed by developers. Apart from creating the code is integrated. This means integration testing happens, and as an end result, you are going to get an integrated code and the integration test results also. So once you get the integration, so once these 3, the view, buy and sell modules are integrated, that means I have my whole website, correct? This is when once the integration testing is done and it is passed, that is when this software is available for the testers to test. So let me come back here and look at what the QA team does while the coding is happening. So we have created the high level test scenarios. So that doesn't mean that while the coding is happening, the testers sit idle and have nothing to do. That's not the case at all. There is a parallel activity that the testing team does while the coding is happening. That is called the test case creation. So we'll just take a little detour here and try to see what a test case means. At this phase, what we do is test case creation. So once we come to the test case creation, we will have a better understanding of how much time a particular testing takes, and how many resources we need. So we'll have a good understanding of how the testing phase is going to go. Here, what we are going to do is, we are again going to update the test plan with the latest information that we have. Okay. Alright, so that is the parallel activity that the testers perform. So now let's see what test case means. Okay. Test case is nothing but a set of steps, or a set of instructions that a tester needs to perform on an application to uncover errors. So what does that mean? Let's go to an example. Okay, let's take Amazon.com. So this is my website. Now I need to test the functionality of say searching for an iPhone. Okay, I'm just giving you an example. Now what are the steps that I need to perform? I'm going to search, and I went to cell phones, and here I type iPhone, and I choose one, and this is the result that it displays me. So I say I'm a tester and I'm testing the functionality of searching for a certain cell phone on Amazon.com. The instructions that I'm going to write is, first, so let me write that down. So the test case, my test case will be first the steps, right? Launch Amazon.com. Then choose the cell phone item from the all drop down list in the search field. Search box. Right? So these are the steps that I performed on the application. So listing out these steps in the form of instructions, this is a test case. Again, there are different fields involved. For a start, let's just understand that this is the way a test case is written. So for every functionality that you identify that you need to test, so here you've written test scenarios. So if you see the test scenario for this test case would be like, test the search feature. Where a test scenario is a one-level definition of what you want to achieve, the test case is a detailed instruction of how you are going to achieve the certain task that you want to test. So this is the detailed level of test cases that QA teams perform at this stage, right? So again, as I said, unit testing and integration testing are something that don't involve the tester. Those are the aspects that are performed by the development team. Okay. Next is test phase, right? The testing phase. At this phase, what happens is system testing happens. Now let me explain what system testing means. So we've seen what unit testing is and what integration testing is, right? Both of them involve checking the code. So let's say this is the pieces of code that are involved in the view functionality. This is the pieces of code that are involved in the buy functionality. This is some lines of code involved in the sell functionality. So when I'm looking at this, these pieces of code and the code that interacts with each other, these two are unit and integration testing, correct? So this form of testing or this method of testing is also called white box testing. Since you are actually involved in the looking at the code itself, these two techniques are called the white box testing. But as a tester, I am not concerned about what is inside this. I'm only concerned about what the view is doing, what the sell is doing, what the buy is doing, or if I'm able to use these features, integrated with one another as a end user. Again, I don't care about how the software is interacting internally. I'm only worried about the inputs I'm providing and the output that I'm doing. What happens in the middle as a code, I am not concerned with it. So this is as good as a black box for me. So the next phase of testing that we are going to perform is the black box testing. Okay, black box testing is also the system testing. Here, so this involves two phases: system testing and UAT. So UAT is nothing but user acceptance testing. We'll talk about that in a bit. So this is the black box testing that we perform. Most of the time in our experiences as QAs, we are going to be involved with black box testing. White box testing is, again, there might be a dedicated white box testing team, but then there are people who have good understanding of the development platform, not us usually. So again, as I said, the black box testing phase consists of system testing and the UAT testing. So system testing and UAT testing, the teams that are involved basically is the QA team. I'm sorry, I put this there. So anyways, the people who are involved in the coding phase again are the QAs and sometimes the data architects also, because they are the ones who will design on how the database should be, or what modules need to go where. So the data architects are sometimes involved, and the database admins are involved sometimes. The dev team basically is the primary focus of this phase. Sometimes the BAs are involved. So all these people are involved in the coding phase. Coming to the testing phase, the QA teams again are the primary focus. BAs could be involved, PMs could be involved to basically understand where we are at with the project. In the system, sometimes in the UAT, users are involved. Again, as I said, we'll discuss about that in a minute. At this phase, what happens is all the test cases that we have created in the previous case are executed. So test case execution happens, which means you are going to perform all these steps and see whether these steps are resulting in the expected way that you expect the site to perform. Okay. So test case execution is done. If at all there is any deviation from the accepted behavior, you are going to find defects. So defects are managed in this step. The input for this step definitely is the test case document that you create. Right? You are going to create test cases in the previous step. So that becomes your input here, and the output is going to be the status reports. So execution, test case execution status report, and probably defect status reports, bug reports, or other all kinds of reporting happens here. And now let's come to UAT. Once the testers have understood, tested. So okay, let me come back to system testing. Say in the test case creation phase, I have created 100 test cases to test my view, by, and cell functionality, right? So 100 test cases, I'm going to, I have written 100 test cases in order to be able to test each of these functionality very, very thoroughly. Okay. So the system testing phase will involve testers, how many ever they are, depending on the magnitude of the project and the timelines. So a certain number of testers are going to execute all these 100 test cases, and then they are going to come up with results. Now, there is a slight differentiation in the role of testers that we need to understand. Testing is a phase that is not responsible for defect fixing. Testing is not defect fixing. Testing is only finding the defect and reporting, right? The fixing is basically the developer's job, correct? Now, once we test, we are going to find defects. That is a given. Defect-free product is something that just does not happen. So, say I tested 100 test cases and I found 10 defects, right? And eventually, over the period of time, after a couple of rounds of testing and fixing and things like that, I'm left with 3 defects. Does that mean I'm going to test over and over again? Not really, because there are a lot of factors. Testing needs time, testing needs people, so I'm not going to be able to test indefinitely. But then this product is okay with going with these 3 known defects, and we'll be working on fixing those defects probably after the after the code is sent out. Okay, so this is the result of my testing. So I have executed 100 test cases and 3 defects are there. And as a testing team, I'm okay. So it's a business decision to say that these 3 defects are still okay for the product to go into production. So basically, the test team gives a sign off. But once the testing team gives a sign off, this is the end of system testing. This is the end of the system testing phase. So once the system testing phase finishes, that doesn't mean the testing phase is complete. The people who have actually requested for the software to be built are the clients, right? The client has to be able to use the software and decide whether it came out the way he wanted it to be or not. So basically, that is what UAT is. The real users are going to test the software and give their sign-off. That is what is UAT. There are 2 phases, there are 2 types of UAT testing, alpha and beta. Alpha testing is when the users test it in the test environment. Beta testing is when users test it in the real-time environment. Okay. So if I have to explain this with an example, the real-time and the test environment, say I'm the Bank of America teller right? The person who stands behind the counter and helps you. And I have been using the internal computer for a while, and I have decided that there needs to be a new button. Correct? There needs to be a new button in my website. So that is the request I've made, and the people and the software service provider has built the software for me, providing me the button. So if I am testing this functionality at the software service provider's environment, that becomes the alpha tester. But if I am actually doing it at my own Bank of America site, that becomes the beta test. So these are two types of testing. So UAT is basically done by the users. So we have said in our example that there are 100 test cases. So do you think the users are going to execute all the 100 test cases? No. It is the job of the QA team to identify the most critical test cases that simulate the real world usage and come up with a subset. So probably 10 or 15 of the main test cases are given to the users, and clear-cut instructions are given on how to use the software, and then the user will be able to execute those test cases and sign off whether the product is according to the way they like it or not. Okay, so that is the UAT. The involvement of QAT at the phase of UAT, in the UAT phase is sometimes minimal, sometimes a lot. We will discuss the UAT at length, at a greater detail later on, but for now this is the overview. So that's what happens in the test phase. So at the test phase, the testers test it, the users test it, both of them they give a sign off, and then the product goes for deployment. Deployment in the sense, the actual push into production. Okay, so the product actually goes live, right? In that phase, it actually goes live. So this is basically the 6 steps of the software development lifecycle. I would like to add another column here and write what is an environment. So basically, until here, the coding, everything happens in a developer's environment, right? And this happens in a QA environment. The testing phase happens in a QA environment, and the deployment happens in the production or the real-time environment. So every project, every software project has at least these 3 environments. The development environment is basically where the developers work on the code. So it is very important to isolate these environments to be able to effectively test the project. The reason is, say I have this, so again coming back to our example, we have view, buy and sell, right? So this is my environment. This is the servers, the databases. This is where I'm writing my code for view. I'm done writing the code for view. I have given it for testing. Correct? And if I'm actually so while the QA team is testing the view functionality, the development team is actually building the buy functionality. If it is the same environment and I'm building the buy, there is no guarantee that the view results will be consistent because of the changes happening to the code. So it is a good, it is a common practice that the QA and the dev environments are separate. The same with the same logic, there is a different environment for production, which is actually the real-time environment. That means it goes when it goes live. That is when it is available to the end user. So this finishes our topic. I'm going to quickly give a recap, and probably this will actually summarize the whole concept that we have learned so far. Okay, so to start with, it has these 6 phases: initiate, define, design, build, test, deployment. We have also understood the concept of QA and QC and how QA's involvement from the beginning in a project can actually detect, prevent errors from happening early on. So QA, quality assurance processes, are basically aimed at defect prevention, and quality control, which is the testing activities, their primary aim is to find errors, which is defect detection. Okay, QA and QC are defect creation and defect detection. Now the people involved in the project. To summarize, first thing is the 6 steps, and then QA versus QC is something we understood. Excuse me. QA versus QC is something we understood, and the people involved throughout the projects are project managers, business analysts, quality analysts, and testers, individual testers, the development team, data architects, and then there might be database administrators. So these are basically all the teams that are involved in the in a project, and then the environments. So basically there is a QA environment, there is a development environment, and there is a production environment. There could be more in some projects, there could be many more, there could also be a staging environment in some projects, but generally having these three is the norm, okay? And then what are the documents that are involved? First, there is a BRD, business requirement document, and there is an FRD, functional requirement document, TDD, the technical definition document, there is a test plan, there is a project plan, and then there is a test case documents. So basically a high level understanding of all the documents that are involved during the SDLC process. And also coming to our specific testing, the phases of testing are unit testing, integration testing, system testing, and UAT. So these are the 4 phases of testing. These 2 are white box and these 2 are black box. So these are the testing techniques that we have. So this is actually a wonderful concept to get a good high level understanding of everything that happens in a software testing project. So that finishes our main topic for today. Now I can take any questions that you have. Farzana has a question. Is it necessary to know programming language or scripting language for testers? Farzana, to answer your question, it is not mandatory, but it is always desirable to have a good understanding of programming language, because manual testing is the first stage of your testing career, and when you want to venture into automation testing, it is a good practice to learn the language that any tool that you choose uses. So a good basic understanding, again an in-depth knowledge is not required, but a good understanding is always desirable. So I'm going to unmute all the participants now. If any of the team members have any questions, I will take them now. Anything, team?
I just had a question I said.
Who performs unit and integration testing? Unit testing and integration testing are typically performed by the... Yes, Jim, there is a lot of noise, so I'm going to mute while I answer this question. Okay, I think it's better now. The difference between who performs unit and integration testing? It is the development team who performs unit and integration testing, because as I said, it involves a lot of understanding the code and all the technical details. So it's usually done by the development team. The recorded video is going to be available to everybody. After the session, you're going to receive an email from me, and you will have instructions on how you will be able to access the recorded video. Okay. Anything else? The ebook, yes, that's a good question. Ebook also, you're going to receive the ebook probably today or tomorrow. Vijay is going to give you all the details about how to access the ebook and how you'll be able to download it. So you will be having that information shortly in a day or two. Sure, I can email this spreadsheet along with all the other information that I'm going to send out. Definitely, absolutely. I'm going to email the training plan also. Again, bring in your questions. If you have any questions, I'll be very, very happy to answer. So you really don't have to stick to this plan. If there is another topic in mind that we need to discuss, or if there is another way that this class needs to go on, we can keep that open for changes. So Seema's question is, how come UAT comes under black box testing? Okay, I'll explain that. That's actually a wonderful question. So let's assume I'm the client, right? I'm the one who has requested for the software to be built. Again, you buy, sell some of the features, correct? Now, if I'm the client who does not understand the software, will I be able to go in depth and understand the code that is within the view module? No, right? Basically, UAT is performed by users. Who are these users? They are representatives from the client. Basically, say if I'm a car dealer, probably the person who is going to use the software the most is going to test it. So in this case, my user is a car dealer, right? Will a car dealer have an in-depth understanding of the Java code that the view functionality is written in? No, correct? So that is why the person is going to only, when he wants to view a car, he's probably going to search. This is the Java code for the view functionality, and at the end, search results might get displayed. So as a end user or somebody who is non-technical, I don't understand this. For me, this is a black box, right? That is exactly why the UAT is also a black box method. You are not going to learn the technicalities or the coding language or the coding conventions. That is immaterial to us. What we are concerned with is when you provide the right input, the right output is coming or not. Okay, did I answer your question, Seema? What about RTM? Can you elaborate what RTM means? Is that an acronym for something? Requirement traceability matrix. Yes, that's a good concept actually. We are going to deal with it later, but for now let me explain it to you on a very high level. We are going to have a detailed session on traceability matrix going forward. So now that we have seen here, what happens first? First is the client comes up with a client's requirement, correct? So first step is client's requirements. And in the next step, what are we going to do? We are going to understand in the design phase, what do? We are going to create the high level product requirement, correct? Or the functional requirement. So high level functional requirement. And then what is happening in the design phase? A technical requirement is formed, right? And then QAs, what are the QAs doing? We are creating the test scenarios, eventually the test cases, and then once the test cases get executed, we are going to find defects. So basically these are all the testing artifacts, right? Now traceability matrix is nothing but making sure that every requirement that the client specified are being addressed in the product requirements, and every product requirement that has been defined are addressed in the technical requirements, and all these three levels of requirement that we have are included in the test scenarios. Basically, the traceability matrix, it means that it will give you a good idea of coverage. So let me draw up a sample traceability matrix. So for example, the client's requirement is this. He said that, build a car type, right? Now the functional requirement is view by sell. And the technical requirements usually are not considered at this step, but if you want, you can. It is, and then the test scenarios. So for viewing, I probably came up with, say, test view and test view after clearing the previous results, something like that. Okay, a high level. So basically, when you look at it like this, again the test cases. I'm going to write the test cases. Test case 1, for the sake of creating a sample document, I'm just going to give in some values. And then test case 1, while I was executing, I found defect 1. Okay, so this is basically a skeleton of a traceability matrix. So what this does is it will give you a view, a snapshot of the status, or of the coverage of what the client's requirement is. In this case, we are only considering one requirement, but there might be like multiple requirements. In this case, you will have to make sure that each client requirement is addressed by a couple of functional requirements, and to make sure these functional requirements are tested, the testing team has come up with the test scenarios. So a traceability matrix is a good tool. It's actually one of the best testing tools that we have, that will ensure that we are actually, there is a forward traceability and backward traceability also. Forward traceability will ensure that all the requirements are being addressed through every step of the SDLC, and then backward traceability is when I find a defect here, I will be able to say which requirement of the client it is going to affect the most. So this is one of the tools. When we go forward in the coming sessions, we will actually create detailed traceability matrix requirements, but on a high level, this is what it is. Did I answer your question? Great. Anything else, team? So Seema's question is, who decides about the model and why to use a particular model? That is also a wonderful question, Seema. Who decides about what model to form? Sometimes the model is dependent on the business type. Actually, when we discuss the agile model, you will be able to understand this much better. There are a lot of considerations that actually are involved. The criticality of the business, the time. Who decides? First of all, to answer your question of who does this, the management and the client. So this is not a decision that is up to us. So the clients and the managements, like the PMs and the BAs, these people basically are involved in the decision on to which model to use. Again, why to use a certain model? This is depends on a lot of factors. Say it is a long-term project, right? With 50 requirements that we have, right? In that case, you know that there are only going to be 50 requirements and you need it 3 months down the line, right? In that case, you going through the waterfall model is the best method, correct? This is actually a good opportunity to bring out the negative aspects in the waterfall model that we have. See, the initiate, design, develop, everything is there, right? So these 6 phases we have, correct? For example, in the design phase, if you realize that you are not able to design a particular requirement the way it is supposed to be. So in that case, what can you do? You will have to go back and redefine it and reinitiate it and come back. So that is one of the problems with the waterfall model. If at all a problem arises, you will have to retrace your steps back and do come back from the first to the last step. That is one of the negatives of a software development SDLC waterfall model. So again, to answer your question, say I have these 50 requirements, 3 months of time, and I'm not going to have any changes. In this case, SDLC waterfall is the best model for me. But if at all my project is something like there are going to be 10 requirements every 10 days that come up, and so the development, testing, everything has to happen in parallel. In that case, Agile is the best model. So you will understand this more when we discuss the other models also. Again, this decision is basically pretty much depends on the kind of project or the kind of software that you are developing. Okay. Sure. We can go over what system testing is. System testing is basically testing the software the way an end user is going to see it. So there is a view, car, buy, sell, correct? So if at all I'm doing a system test, it will be something like this. I will go to the website, say there are these menu options. So I'm going to click on the view, probably it is going to show me the models, and then I'm going to choose one, and when I choose one, probably the car details are going to get displayed, and here I might have an option to buy. So I will click on the buy. So this process of, launching the website, going to it, looking at the details, clicking on buy, performing one full operation is basically a system test. So system test is basically performing the operation or, testing the functionality just the way an end user would do it. Again, a black box method. Here you are only concerned with the functionality on the website, not the code. Alright, is that clear? Sure, great. Anything else, team? So if there is nothing else, I want to get to the part of today's assignment. As a general practice, I always start with the participants gathering some requirements. So as today's assignment, what I would want you all to do is pick up an e-commerce site. You could pick Amazon or anything else that appeals to you. Pick up this site and list out 10 requirements that the Amazon business people would have come to the client to build. So let me give you an example of that. So here is Amazon.com. What does this site facilitate me to do? Now when I look at here, there are all these, there is a left navigation where I'll be able to choose a product, right? And then there is a search functionality where I can filter according to the category, correct? So now a sample requirement of Amazon.com would be user can register and buy a product, right? This is one requirement. The other requirement would be user can buy a product without registering. Or search, you can search for a product and it will display recommendations for you, right? So again, as I'm saying, come up with 10 of the functionalities or 10 of the activities or features, tasks that Amazon.com can perform. The reason why I make this the first assignment is, when you understand how a site works or how a particular product or application works, it is very, very easy to come up with test cases. It will be very easy for you to test it. First, the whole basis on what you can start your testing is to understand how the software works to begin with. So that is the today's assignment. Go ahead and write 10 features, 10 activities or 10 tasks that any site, an e-commerce site in particular, can perform. So that is the assignment. And another assignment is, I'm going to create a sheet or an Excel sheet, and I'm going to share that information with you. So basically what that Excel sheet is going to contain is, I would want to understand where are you at your in terms of your careers. Like I would like to get a little understanding of your educational backgrounds, and if you are already into IT, I want to know what kind of work you're performing. This is because to tailor this course to suit the needs of the participants that are here. So that I'm going to send out that Excel sheet, and please fill that out for me and let me know.